Hi everyone, welcome to my channel Open Academy for you. So in this tutorial, we are going to see how to perform machine learning of a sample dataset using R, and we are going to run our program in Colab. As you all know that Colab is mainly used for development of Python applications, but in this tutorial we are going to see how to run R based applications in Colab. So let's start the tutorial. The first thing is you have to create a Jupyter notebook in Colab, and we have to initialize our environment. So that can be done by going to your Google Drive. So first thing you have to do is go to your Google Drive, select a folder of your choice. So here I have selected my folder Raju DL. So in this particular folder we have to run a link which is https Colab research, and this is the link Colab research google.com notebook create true language is equal to R. When you run this particular line URL in your folder, it is going to create a Colab Jupyter notebook based on R environment, because we have stated language is equal to R. Go ahead and run this particular line. So when you run this particular line in your folder, a Jupyter notebook is created like this. So let me change the name. So we are going to do machine learning of data. So we can rename here. The thing is, we are going to take a dataset from Kaggle. So the dataset is Pima Indians Diabetes Dataset, and here we are going to predict the onset of diabetes based on diagnostic measures. So if you try to refer this web page, you have more information regarding this dataset. The database consists of a group of Indians, Pima Indians, who are all female, at least 21 years of age. So different parameters such as pregnancies, their BMI, insulin age are all collected, and they try to find out whether the subject is diabetic or non-diabetic. So that is our outcome, the target. So we are going to use this data set for our machine learning approach. Come back to our notebook. The first thing is we have to install various libraries for our machine learning. So that can be easily done in Colab. First thing is we have to load the library. The first library I'm going to load is Tidyverse. So go ahead and run this particular cell. So this is going to run on the cloud, and if you try to see here, it is allocating resources for this particular instance. The best thing about Colab is it is freely available to us. So all it requires is a Gmail account, and if you have that account, you can very well use this particular Colab. So now it is running, and we have loaded the Tidyverse into our instance. The next thing is we have to load the dataset, this particular dataset for our machine learning. So you can do that by many ways. So one method I'm going to follow here is I'm going to store that dataset in this particular data frame named as data, and we are going to use this command read.csv, and we are going to read from a URL. So this is where we try to provide the URL. So I'm going to copy this diabetes dataset from my website datalifex.in, dataml diabetes.csv. So can use you can load a copy of this CSV file in your drive, and you can store it in this particular data frame. This is also an alternate method. As I have a copy of this particular data set in my website, we can very well read from this particular URL. So go ahead and run this particular cell. So now it will read the CSV file from this source, and it is loaded into this data frame data. So no error, so it is loaded. Go ahead and check the data frame. So the first thing you can do is check for a few observations, and you can see that this is loaded. So here you can see that there are different predictors: pregnancy, glucose, blood pressure, and this is the outcome is the target. And here you can see that it is given as 1 and 0. 1 is for diabetic condition, 0 is for non-diabetic condition. So next thing we have to do is we have to load a library for performing machine learning and various pre-processing steps. For that we require library caret. So this is the library we try to load. So this has all the subroutines for performing machine learning in R. Go ahead and load this library, and we can see that there is an error because there is no package installed here in our instance. So we can easily install a package, missing package, by typing this command. So caret, and run the cell. So this is the syntax for installing a package in R. So install.packages and the library we want to install. So here I'm installing caret, and it will install all the required dependencies based on the library you want to install. And let's give it a minute. So caret is a classification and regression tree library in R, which is very commonly used in machine learning. So it has all the models, it has the various provision for training the model, it has pre-processing functions where we can use it for normalization of features. It has feature selection procedures, functions. We can use it for our application. So it is getting installed, and the thing about this particular Colab is, you can see here we have using a instance of a Google Compute Engine. The RAM provisioned around 12 GB with a disk space of more than 100 GB. So this particular instance is allocated to us free. So very well we can use it and for developing our applications. So it is getting installed. Before that, whenever you are having a data set, we have to check for any missing value or inappropriate values. So whenever you are having a missing value, we have to go for cleaning of our data set. So here you can see that we are not having any missing values. So it is actually a clean data set what we have got from Kaggle. So you can see that it is having all the values. Now the package is installed. Anyway, the first thing you have to do is, once you have loaded a data set, is getting the summary statistics. So go ahead and run summary data. So here you can see that it has populated different descriptive statistics for each predictor variable. from pregnancies to age. What is the minimum value? What is the first quantile? What is the median? What is the third quantile and maximum value? And here you can see that the outcome is also, the statistics for outcome is also calculated, but as it is considered as integer, it has provided various values. Generally speaking, we have to make the target variable as the factor variable in R. So whenever you are performing classification, we have to find out what is your target variable, and we have to declare that factor variable as a factor. So this can be done in R by the statement select the particular predictor. So data $ outcome, then I'm going to make it as factor by calling this function as dot factor and giving the same outcome. So what we have done in this particular statement is we have taken that outcome, we have selected that outcome and making it as a factor variable by running the statement as dot factor target variable. Now again you do the summary of the data. Now you can see that it has been converted into different levels. So you can see that 0 and 1, we are having observation of 500 for 0 or non-diabetic subjects, and we are having 268 observation for diabetic subjects. So it is important that you identify your target variable and convert it as a factor variable for machine learning in R. So as we have loaded with the dataset and the library, we can go ahead. The first thing we have to do is we have to do a normalization. As you can see that here we are having different predictor variables and they are having different minimum and maximum value. So it is generally suggested to normalize our features in the range of 0 to 1 so that we can have a proper machine learning. Otherwise the predictors would be biased and your model won't be trained properly. So this can be done by a pre-process method which is available in R. So what you have to do is, first you have to load the library. So let me load the library, and this is the statements for normalization. So what we have done here is we have first loaded the library caret because this particular package is having the normalization function pre-process. So what I have done is I have first loaded the library and I have created a object preprocess underscore range underscore model tr, and we are using this function preprocess for normalization, and you have to pass the data which is our data frame and the method is range. So now this is where we try to initialize the preprocess model, and using a predict method I'm going to normalize the features using the method range. So here we have to pass our data, which is data frame. So you can see that. So by running this line predict method, you're going to normalize the feature, and here I'm just changing the outcome to a character variable because that is how it is given to whenever you are using a caret package. So instead of zeros and ones, we are using class 0 and class 1. It is better to have the outcome, your target variable, as a character variable. So that is done here. Go ahead and run this cell. So now we have loaded the package and we have done the normalization also. How to check whether the normalization is done or not? We just run the normalized data. So now will be giving this data frame because this contains the normalized features. So head train data. So here you can see that it is normalized. You can also get a summary of the normalized data frame. Train so when you run summary train data, so here you can see that it is normalized. The minimum value is 0 for all the predictors and it is maximum for all the predictors, which is 1. So in this way we are normalizing the features. This is very important pre-processing step when you are using a machine learning approach. And we have changed our target to a character variable, class 0 for non-diabetic, class 1 for diabetic. So next we can go for the machine learning. So before that I have to initialize a fit control for our models. So fit control is where you initialize the hyperparameters of your training models. So here we try to invoke this function train control. So there we try to specify the type of cross validation. So method is equal to CV means we are going to use a cross validation. Number is equal to what type of cross validation. In this case we are using 5, and we are going to save the predictions as well as the class probabilities, and we are going to use a 2-class summary performance metrics. So this various parameters are stored in this train control data frame. So now it is stored. Next thing is we have to call the different models. So I am using 3 models for training this diabetes dataset. So model 1, 2 and 3. The syntax is very simple. Train. This is the function we try to use it for training our models. So this is the formula statement in R. So here the first value is the target one, the outcome, and if you are using all the predictors features, you have to just put a dot. So R will understand that you're going to use all the predictors for training the model. So this is where I pass the data. So data is our normalized data, so train data, and what machine learning model we are using, that we have to specify in this method. So method is KNN for the first model. For the second model it is SVM using radial basis function, and third one is the random forest. And tune length is the number of parameters we want to tune for each model during the cross validation process. So that is given here. And this training control is the various hyperparameters for the training subroutine, which is specified in the previous cell, the fit control. So we try to pass the fit control to the training control in this particular statement. Go ahead and run this models. So we are hit with an error. So we have to install this particular package, Colab. Whenever you want to install a package missing a file, you have to type in installer packages and particular library. So Colab we have to install. So it is installing. Give it a minute. So this is used for, this particular package is used for SVM radial. So it is getting installed. So now it is installed. Again run this particular model cell. Now it is getting trained. Okay, all the models are trained. So what you have to do is we have to check the performance. So you can run the statement. So what we are doing is we are storing each model in a in a list and we are storing it in a data frame, again we are calling the summary function to get the summary of the various models. So here you can get the summary of the trained models. So ROC is the area under the curve value, so it is specifying the AUC based on this ROC plot, and you can see that whenever that ROC value is 1, it means the classification is good, and you can see that SVM has provided the highest AUC for the ROC plot, which is 0.833. so this has to be close to 1 for ideal classification. Likewise, sensitivity is calculated, and you can see that the mean value for random forest is high, 87%, and you can see the specificity. The specificity is less, and the highest recorded is used for SVM, which is 57%. You can also have a very nice representation in a graphical plot by running the statement. So if you run this particular statement, so you can have a representation of the various performance metrics using a box whiskers plot. So here you can see the performance metric of all the classifiers, SVM, KNN and random forest. So by this you can have some idea about the performance of each classifier. So you can see that there is scope for improvement of the models, as we have taken only 2 parameters for tuning our model. So you can increase the number of parameters, accordingly the model will train for different parameter values and the best value is taken. So one thing is, if you increase this tune length, more parameters are added, it is going to need more training time. For our tutorial, we have taken a simple approach of tuning only 2 parameters for each model. So you can increase the number of parameters to get better accuracy for the classification problem. I hope this covers the important pipeline of any machine learning approach. So what you have done is, we have used 3 models for detection of diabetes based on diabetes dataset obtained from Kaggle. So if you like this video, kindly like it and subscribe to this channel for more videos like this. Thank you.